Hey everyone, I want to talk to you about absorptive and post-absorptive states of feeding. So the absorptive state, what does that make you think of? Absorption, right? This is when your body is actively absorbing the nutrients, right? So it takes place up to 4 hours after feeding. What do you think is going to be a hormone that is active at that time? Here, let me step over here. What hormone is going to be active? Insulin, right? Our blood glucose is going to be higher. And insulin is one of those humoral hormones. So it's going to respond to that increase in blood glucose. It's going to, well, the pancreas is going to respond, release insulin. The insulin is going to trigger the uptake of glucose by the cells to lower blood glucose. And it's also going to work with the cells to initiate some anabolic processes. So exactly what anabolic processes are going to happen? Well, the glucose is going into the cell, and we're going to have glycolysis taking place. That's not anabolic, is it? That's catabolic. So the anabolic ones, glycogenesis. When we have excess glucose, you can form glycogen. Glycogenesis by the liver. Okay, amino acids are going to be made into proteins, and fatty acids are going to be you're going to have lipogenesis, the making of lipids, and this is going to take place in the liver and in adipose tissue. So it's things you would expect, right? You have glucose in the bloodstream, maybe in excess even, so we can store it for later use. Oops, not there, right here. Glycogenesis, the stringing together of glucose molecules. We can convert our amino acids into proteins, because when you're feeding, or just after feeding, the glucose will be higher, but there will be more amino acids in the blood too. And fatty acids, you can do lipogenesis. You can make lipids, right? Well, what about after those 4 hours have passed? Then you're in the post-absorptive state. So post-absorptive is passed over 4 hours after feeding. So this happens, in the late morning, in the late afternoon, and throughout most of the night. All right, hormones involved, what you would expect. Glucagon, but look at this, epinephrine and also norepinephrine. Might not have been a guess. But think about it, like your body is under a little bit more stress, right? And epinephrine can trigger lipolysis in the liver and glycogenolysis in the skeletal muscles. Now, this makes sense, I think, especially in the skeletal muscle. Think of epinephrine as fight or flight, and so now you have more glucose in your skeletal muscle, and it can release it, and it's now available. All right, what else is going to be taking place? Well, you're going to have more catabolic processes now. So protein catabolism, you get amino acids, which can be glucose or acetyl-CoA, either way. You get ketogenesis, which will generate ketone bodies, which can then be used by some tissues, such as the brain. In a state of starvation, the brain can use ketone bodies. And glycogenolysis. So before we did glycogenesis, here glycogenolysis, you're going to lyse or break down that glycogen that you formed earlier. So now you release the glucose that you stored up earlier. And also gluconeogenesis. What is that? Let's take that word apart. So we have and neogenesis. Glucose, new, genesis. The making of glucose from non-carbohydrate materials. If that makes sense. So you're making glucose from carbohydrate materials, like new materials. Neo. Gluconeogenesis. Does that make sense? And you've got glucagon and epinephrine as your hormones here. Right over here you've got insulin. You're doing mostly anabolic processes. And here you're doing mostly catabolic. Does that make sense, everybody? It's a fun concept. And a fairly easy one, I believe. So hopefully that'll be an enjoyable exam question. Alright, see you all later.